All right, my seventh grade friends. Today we're going to be talking about a little bit about real numbers. Okay? Now, really, our focus today is on the two groups of real numbers. All numbers, positive, negative, decimals, fractions, square roots, decimals that terminate, decimals that repeat, square roots that are perfect, square roots that are not perfect squares. All of those fall under the group real numbers. Now, within real numbers, we have two succinct groups. Okay? The first group is what we call rational numbers. Rational numbers, and you see kind of the word ratio in rational, can be written as a ratio. To say something can be written as a ratio is just kind of a fancy way of saying it can be written as a fraction. So, for example, 3/7 would be considered a rational number. A decimal that terminates, like 2.58, would be a rational number. A decimal that repeats but does not terminate. It repeats but does not terminate, such as 4/10, and the 4 just keeps on going. That's considered a rational number because this could be converted into a fraction. Now, within rational numbers, we have another group called integers. Integers are kind of your negative numbers, such as -1, -2, -17. And within integers, we have another smaller group known as natural numbers, which are kind of your counting numbers, like 1, 2, 3, and so forth. Now, our other group is what we call irrational numbers. An example of an irrational number would be pi. When we think of pi, we think of 3.14. But pi, as I've said before, is just a continuing number. It does not end. It does not terminate. It does not repeat. It's just random. There's no real pattern to it. That's an irrational number. If I was to take a number like -7 and multiply that by pi, that would be an irrational number. A number that does not have a perfect square, such as the square root of 53. 53 does not have a perfect square. Okay? Thus, it is an irrational number. You're going to have one set of directions that you're working with today, and we might have to refer back to this. But the directions that you're working with today simply say, tell whether the number is rational or irrational, and then explain why. All right, so let's kind of look at example number 1 here. All right, let's say we have 0.232332333, and this pattern were to keep going. Okay, this would be an irrational number. Why would it be an irrational number? You might say, well, Mr. Swack, there's a pattern. Okay, well, a pattern does not make it rational. Okay, it is rational if it repeats but does not terminate. This does not repeat. It's 2, then 3, then 2, then 3, 3, then 2, then 3, 3, 3. And common logic would say, well, then we would have another 2, then we would have 4 3s, then we would have another 2, then we would have 5 3s. So it's not repeating, even though there's a pattern. It's irrational. Why? Decimal doesn't repeat or terminate. In 7th grade, you're going to have to explain it. You're going to have to write that down. All right? Let's look at number 2. Say that I have the negative square root of 144. Well, I know if I plug 144 square root into my calculator, I find that 12 is the square root. So 144 is a perfect square, which means this number would be negative 12, which would just be an integer. So it would make this a rational number. Why? The explanation can be very basic. It's a perfect square. Let's look at one more. Say number 3, the square root of 31. If I go and plug 31 and then the square root button into my calculator, okay, I would see that it just kind of continues. It's not a perfect square, okay? So this would be irrational, okay? Why? Not a perfect square. Just a couple of others, just to make sure we're not confused. Let's say, for example, I had the number 0.7 with a line over it. It meant that the 7 kept continuing. It's repeating. So this would be rational. Why? Because it is a repeating decimal. And the last one that we'll look at, we'll say, let's go 7 over 9 as a fraction. Well, it's a fraction. It's written as a ratio. That makes it a rational number. What's the explanation? Okay. The explanation can be basic. You don't have to write some big old book. It's a fraction. It's written as a ratio. Thus, it is a rational number. That's what you're doing today, 7th grade. That is it. Think you can handle that? I'll be available to help on Wednesday, April the 22nd. Talk to you later, 7th grade friends.